Okay, proving limits by using definition of the limit. Let's prove that limit of x squared as x approaches to 2 is equal to 4. First, what is the formal definition of the limit? If f is a function, if f is a function defined on an open interval containing b and possibly not defined at b, then the limit, it's possible not necessarily to be defined at b, as x approaches b equal L if for every epsilon, if for every epsilon positive very small number, there exists a delta which is a function of that epsilon. It should be positive such that right, whatever absolute value of x minus b is included between 0 and delta, then for sure absolute value of f of x minus L is less than epsilon. This is the definition. How can we start here? What shall we do? We should find this delta, which is a function of epsilon, right? We should find that delta, which is a function of epsilon. So suppose that this epsilon, this epsilon is more than 0 for sure and less than 4, less than L. Okay. First, what is x squared, absolute value of x squared minus 4? Absolute value of x squared minus 4 is less than epsilon for sure. Is less than epsilon. So we are talking about this here, absolute value of f of x minus L less than epsilon. This implies, right, minus epsilon less than x squared minus 4 less than epsilon. This means that, let's continue here, this means that let's add 4 to all sides. Okay, it's 4 minus epsilon less than x squared less than 4 plus epsilon. Let me go and find x, so I have to make radical to all these positive sides. So it's 4 minus epsilon inside radical less than x less than radical 4 plus epsilon. We don't need x. What do we need to prove? That absolute value of x minus b. So what b we have here? As x approaches 2, this means x minus 2 approaches to 0, right? So b is 2 here. So we have to subtract 2 from all sides. Modulus radical 4 minus epsilon minus 2 less than x minus 2, which is less than radical 4 plus epsilon minus 2. That's great. What else we can do? For sure that radical 4 minus epsilon minus 2 is less than minus radical 4 minus epsilon plus 2. Is that true? Because 2 minus this value is more than this value minus 2, right? So it's less than x minus 2 less than radical 4 plus epsilon minus 2. Why I chose this value here? Because it is negative. Factorize, take negative outside. It gives me the negative part, right? The negative number, the opposite number of this. This value here is positive, is the same as this value multiplied with minus, which gives me that absolute value of x minus 2 is less than radical 4 plus epsilon minus 2, which is simply a positive value, the absolute value of x minus 2. And what is that 2? This absolute value of x minus 2 is less than radical 4 plus epsilon is slightly more than 2 minus 2, so what left is epsilon. So what do we have here is this, right? And this value we got, which is slightly less than epsilon, is delta, which is a function of epsilon, So we can say that here, that 0 less than absolute value of x minus 2 less than this delta, which is a function of epsilon, which is equal to radical 4 plus epsilon minus 2. Now, simply this definition ensures to us it ensures to us whatever 0 less than absolute value of x minus 2 less than delta, then f of x, absolute value of f of x minus L, which is 4, right, is less than, which is equal, right, here x squared is the function, minus 4 is simply less than epsilon, because delta is less than epsilon already. Therefore, the definition of the limit exists. Limit of x squared as x tends to 2 is equal to 4. And that's it. We have time. Let's do another one. Let's do another one here. Let's try to take another definition, another limit by definition. Limit of radical x is equal to 2 as x tends to 4. All right. Let's try to solve this one together. Okay. Same. We start with absolute value of radical x minus L, which is 2, is simply less than epsilon. What's that mean? This means minus epsilon is less than radical x minus 2 is less than epsilon. We need to have the radical x, so we add 2 to both sides. This implies that minus epsilon plus 2 less than radical x minus 2 plus 2 less than epsilon plus 2. We don't need radical x, we need x. We need as x tends to 4, right? Or means x minus 4. So we square all sides. Minus epsilon plus 2 all square is less than x less than epsilon plus 2 all square. What else? Let's square it. Let's square all sides. It's epsilon square minus 4 epsilon plus 4 is less than x, which is less than epsilon square plus 4 epsilon plus 4 using identity a plus b square. Now let's subtract 4 from all sides. It's epsilon square minus 4 epsilon plus 4 minus 4, 0. It's x minus 4 and less than epsilon square plus 4 epsilon plus 4 minus 4, which is 0, right? What else? Simply this number here, epsilon square minus 4 epsilon, which is less than x minus 4, is less than minus epsilon square plus 4 epsilon. For epsilon, minus epsilon square is more than epsilon square minus 4 epsilon, which is less than epsilon square plus 4 epsilon. So absolute value of x minus 4 is less than, right, is less than 4 epsilon minus epsilon square, because this value here we can say it's minus into 4 epsilon plus epsilon minus epsilon square, right? 4 epsilon minus epsilon square. So minus times 4 epsilon minus 4 epsilon, and minus times minus epsilon is plus epsilon square. So this value is the negative of that value. So it is included between the x minus 4, the negative of this value, and the positive of this value. So the absolute value of x minus 4 is less than 4 epsilon minus epsilon square, which is for sure more than 0, which this value is the delta we need to have to ensure that we have this definition, okay, which is absolute value of f of x, which is x, right, which is radical x minus 2 if less than, okay, like we did here, if less than epsilon. This is less than epsilon, right? This means we have x minus b in the absolute value.